Hi guys, today's lesson is lesson 97. It is called Graphing Linear Inequalities. Linear inequalities are similar to linear equations. When we have an equation, we just have an equal sign, but today we're going to be talking about inequalities. So inequalities, again, are greater than or equal to, and less than or equal to. In order for something to be a solution to these linear inequalities, it's going to be an ordered pair that makes the inequality true. So let's look at three examples. Are these coordinates or ordered pairs solutions to these linear inequalities? So in A, our ordered pair is 3, -2, and we want to know if that's a solution to this inequality. So anytime we have an ordered pair, it goes x, y. So we want to know, is -2 less than or equal to 2 times 3 minus 8? Is -2 less than or equal to 6 minus 8? Is -2 less than or equal to -2? Yes, it is. So yes, this is a solution to that linear inequality. All right, is 2 -2 a solution to this linear inequality? Is -2 greater than 2 minus 3? Is -2 greater than -1? No, it is not. So no, this ordered pair is not a solution to this linear inequality. All right, how about our last one? Here's our ordered pair, and our linear inequality this time is x is greater than -4. Well, this is our x value here. So is -2 greater than -4? Yes, it is. So yes, this ordered pair is a solution to that linear inequality. All right, what we've been doing before is graphing inequalities on number lines, but these are linear inequalities. So if you think of linear means a line, so we are going to be graphing these on coordinate planes. All right, so let's look at this linear inequality. Y is greater than -x plus 5. All right, would you know how to graph it if it said y equals -x plus 5? You should. This is in slope-intercept form, right? The number in front of the x is our slope, and this is our y-intercept. If we think about y equals mx plus b. So let me sketch this out. 1, 2, 3, 4. All right, we're going to start with our y-intercept of 5. So we'll go up to 5, put a dot, and my slope is -1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and so on. All right, the only difference here is that we have this greater than sign. So if you'll think about if we graphed these on a number line like this, and if it was greater than, we would have an open circle, right? So greater than and less than, these are going to be, it's kind of confusing. These are going to be dashed lines, and I'll show you what that means in just a second. And if we think about, we had greater than or equal to and less than or equal to, if we would have graphed these on a number line, they would have been a closed circle. So these are going to be solid lines when we graph them on a coordinate plane. So again, I have y is greater than -x plus 5. I started graphing it. It's a regular greater than sign, so I'm going to have a dashed line. Lines always have arrows, and now I have to decide which way I'm going to shade. Just like I would have shaded down here on my number line, I have to decide which way I'm going to shade. So I personally like to pick the origin as my test point. So the origin's coordinates are 0, 0. So I'm going to take those numbers and plug them into my original equation. So is 0 greater than -0 plus 5? Is 0 greater than 5? Well, the answer to that is no, right? It's not. So I do not want to shade 0, 0. Instead, I'm going to shade the opposite way of 0, 0, which means that any coordinate that is on this side of the line I graphed would be a solution. So one of my solutions could be 1, 6. That would be right about here, right? I could have 3, 4. I could have any point that is in this shaded region of the graph. All right, let's look at another one. I want to have y is less than negative 2x minus 9. So I'm going to start by graphing that. 1, 2, 3, 4, 5, 6, 7, 8, 9. My intercept is negative 9, and my slope is negative 2. So it's going to be a downhill line, right? So I can go up 2 and over 1, up 2 over 1, up 2 over 1. All right, it's a regular less than sign, so it's going to be a dashed line. And now I need to decide which way to shade. So I'm going to test the origin again. So is 0 less than negative 2 times 0 minus 9? Is 0 less than negative 9? No, so I don't want to shade 0, 0. I'm going to shade the opposite of 0, 0. All right, let's try another one. All right, what if we have y is less than or equal to 1/2 x plus 2? So again, start by graphing. My intercept is 2, right here. So start here. My slope, if you'll remember, is rise over run. My slope here is 1/2, so I'm going to go up 1 and over 2, up 1 and over 2. I could go down 1 and backwards 2. All right, this is less than or equal to, so this time it's going to be a solid line. All right, I'm going to test my origin again. So is 0 less than or equal to 1/2 times 0 plus 2? Is 0 less than or equal to 2? Well, yes it is. So this time I'm going to shade 0, 0. So my solution is anything that's on this part or this side of the line. All right, what if I had a graph, or excuse me, an equation that said y is greater than 3? Okay, think about how I would graph y equals 3. This means that no matter what x is, y is always going to be 3, right? So if x is 0, y would be 3. If x was 2, y would be 3. If x was negative 1, y would be 3. It's going to be a dashed line because it's just greater than. And I want to shade anything that's greater than 3. So if I think about my origin, is 0 greater than 3? Well, no, it's not, so I'm going to shade anything above my dashed line. All right, I know this is a little funky. You can do it. So check out lesson practice on page 651 if you want some more questions. You can also graph all of these at desmos.com if you just want to type some things in and play around with it and see what kind of graph you get. Please let me know if you have any questions. Thanks.